Today we'll be explaining the periodic table in depth.
Here are the topics that we are going to cover today: historical development, chemical families, and periodic trends.
Historical development.
Before the periodic table, scientists created a list of all known chemicals.
In 1864, John Newlands made a chart of all the known chemicals according to their atomic mass. This arrangement was called Octavius' law, which stated that chemicals are arranged according to increasing atomic weight. This was found to be unsuccessful because the arrangement did not predict the reactions.
Then, in 1869, Dmitri Mendeleev correctly grouped the known elements by their chemical and physical properties. The groups the elements were placed in were closely related in how they react.
Chemical families.
This family is the alkali metals. They are most commonly found in salts and the human body. One common characteristic that all of these elements in the alkali family has is that they lose a single electron when they react.
This is the alkaline earth metal family. This family loses 2 electrons in reactions and forms basic oxide that then reacts with water to form hydroxide.
These are the transition metals. They look like metals, they are malleable and ductile, conduct heat, electricity, and form positive ions. They are very similar to the other metals, but transition metals are more likely to form covalent bonds.
These groups don't have a specific name because as you go down, the element switches from non-metal to metal. They sometimes go by the name of the top element, such as boron, carbon, nitrogen, or oxygen family.
These are the halogens. They tend to gain a single electron in reactions and form strong acidic compounds with hydrogen, and from which simple salts can be made.
These are the noble gases. They are very unreactive, and for a long time they were called the inert gases because people thought that these elements wouldn't react at all. Neil Bartlett showed that they require very special conditions, but they could react. After this discovery, they became known as the noble gases.
Periodic trends. Periodic trends are patterns in the periodic table that show different perspectives of elements.
Electronegativity is the likelihood of an atom to attract a pair of electrons towards itself. The trend is, as you go from left to right, the electronegativity increases, and as you move from top to bottom, it decreases. So for example, calcium would have less electronegativity than chlorine.
Atomic radius is the measure of the exact size of an atom. The trend is, as you go from left to right, the atomic radius decreases, and moving from top to bottom, it increases. For example, sodium would have a larger atomic radius than bromine.
Ionization is the minimal amount of energy required to lose an electron. The trend is, as you move from left to right, ionization increases, and going from top to bottom, it decreases. For example, oxygen has a higher ionization energy than potassium.
Shielding effect is a decrease in attraction between the nucleus and the electron, which changes the charge. The trend is, it remains constant as you go from left to right, but increases as you move from the top to the bottom. For example, lithium and nitrogen have the same shielding effect.
Now it is time for the periodic table song to review what we just went over.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine, film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun. Lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62. Samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium. Platinum, gold to make you rich till you grow old. Mercury to tell you when it's really cold. Thallium, and lead, the bismuth for your tummy.
Polonium,
Astatine would not be yummy.
radar,
Francium will last a little time.
radium,
Then actinides at 89. This is the periodic table. Noble gas is stable. Halogens and alkali react aggressively. Each period will see new outer shells will electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, neumecnurium, dubsidium, rhenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson. And then we